Hey everyone, in this video we're going to go through how to identify parallel and perpendicular lines by using just the equation. Okay, so this example here, are the following lines parallel? We have y equals minus x over 2 minus 2, and our second one is y equals 2 minus 2x over 4. Okay, so the way to decide whether these two are parallel to each other, we have to use the gradient intercept form to find the gradient, okay? So whenever we're trying to find perpendicular or parallel lines, we've got to find the gradient. Okay, if they are equal, then it is parallel. If they are negative reciprocals, they are perpendicular. Okay, so that's just generically how to do that. Now let's check the gradients of this. So we want it in the form of y equals mx plus c, so that we can identify the gradient as the coefficient of x. Okay, so gradient is the coefficient of x, or the number in front of the x. Okay, so the number in front of this one, y equals x over 2 minus 2, is actually 1/2. So we can write this as 1/2 x minus 2. So our gradient in this case is a half. Now let's have a look at number 2. We have y equals 2 minus 2x over 4. Okay, which we can simplify as 2 minus 2 over 4 is actually 1/2 x. Okay, so our gradient in this case is negative a half. These are not the same and hence are not parallel. Now let's check whether these are perpendicular. So we have our first gradient is 1 over 2. Our second gradient is negative 1 over 2. When we times those two together, that gives us negative 1 over 4. So therefore, it is not a negative reciprocal. Therefore, not perpendicular, because we need the gradients to equal negative 1. So these are neither parallel or perpendicular. Okay, let's look at another example. Okay, so are the following lines perpendicular? Okay, so let's identify the gradient of this one. So our gradient is negative 1 over 3x minus 2. So our gradient equals negative 1 over 3 because that is the coefficient of x. Now let's have a look at this one. Y equals 3x plus 2. The gradient in this case is our 3, so our second gradient is 3. Now, these are not the same. Does not equal m2, therefore not parallel. But are they perpendicular? Well, it looks like it is, because 3, if it was flipped, and the negative was in front, it'd be negative 1 over 3. But let's check that they times together to make negative 1, just to be sure. Okay, so negative 1 over 3 times 3 equals, let's cross those out, negative 1 times 1 equals negative 1. So therefore, y equals negative x over 3 minus 2 and y equals 3x plus 2 is perpendicular. Okay, let's have a look at one more example. Okay, let's check whether, example 3, whether the following is parallel, perpendicular, or neither. Okay. Let's do 4x plus 2y equals 10, and 4x minus 2y equals 10. Okay, so let's do this. Actually, I'm going to change this. I'm going to swap these two around. Okay, so with these ones, these are in general form. So you're going to have to convert it to gradient intercept form first. Okay, so this one, in gradient intercept form, we have to make y the subject. So we have to minus 4x on both sides. So it's going to be 2y equals 10 minus 4x. And then we're going to divide all of our terms by 2. So it's y equals 10 divided by 2, which is 5, minus 4 divided by 2, which is 2x. So our gradient in this case is negative 2. Now, let's have a look at this one. Make y the subject again. So minus 2x on both sides. We're going to have minus 4y equals 10 minus 2x. And then we're going to divide by negative 4. All of our terms by negative 4. So it's y equals 10 divided by negative 4 is negative 10 over 4, which is 5 over 2. Plus, because there's two negatives, 2 divided by 4, which is 1 over 2x. So our gradient in this case is equal to a half. Okay, so these are not the same. So therefore not parallel. Okay, let's check whether these are perpendicular. So does m1 times m2 equal negative 1? Okay, so negative 2 times 1 over 2 equals negative 2 over 2, which equals negative 1. Therefore, these equations are perpendicular. Okay, so that's how you do, that's how you identify parallel and perpendicular lines that are either in gradient intercept form or in general form, convert it to gradient intercept form, then find the gradient. Okay, if you have any questions, please use the private comments. Otherwise, good luck with the questions.